want to record it for other people who can't come tonight because there are other Zoom meetings, would you believe? Can I ask everybody who is not muted to mute, and people to unmute when they speak, i.e. the two speakers? That would be appreciated. Without going on about muting, I was at a Zoom meeting last night on Reading Hydro, which was very interesting, apart from the fact someone was eating their dinner noisily without muting, and it really detracted from the whole setup. So can you mute, please? Tonight's format is I'm going to show you just one or two slides about Marlow Energy Group and what we're up to, what we do. Then we'll move on to first Tony Cowling of Draft Busters, who will talk about insulation, and then Ed Andrews is plural, isn't it? And yes, Andrews of Instagroup, who will follow, and he'll be talking mostly about the government's Green Homes grants. If you have any questions, if you look down at the bottom of your screen, you'll see right in the middle it says chat. If you hit that, then you're able to type in a question, and Liz Laurenti, who you'll probably see on your screen, is handling the chat questions at the end of these two presentations. And if we have the time, people will be able to ask questions in person at the end. So that's how it's going to work. I'll start off with our little presentation, which is this one. Sorry, I better share screen first. That would be useful, wouldn't it? Right. Oops. Excuse me a sec. I've just managed to delete what I was actually going to present. So let's get that down, and that, and share screen, and excuse me a minute, I do apologise for this. I will be back to you very shortly when I've sorted this out. That looks like it's actually launched it, good. Right, can anybody who's not muted tell me if they can see the screen?
Yeah, sure.
Does it say welcome to our fourth experts? Ask the experts?
Sure does.
Excellent, right. Now I'm going to take that out. Right, so Marlow Energy Group is sponsored or has partners in the 5 organisations you can see before, which cover various things from work to people in fuel poverty to schools and other organisations as well. Marlow Energy Group has some objectives. Please read them. I'm not going to bore you with reading them out. That's the first one. That's the second one. That's the third one. And that's the fourth one. To give you a quick advert for December, on Tuesday the 8th of December, as you see, we've got Ask the Experts on the National Grid explained. That should really be an interesting Ask the Experts. Just as another advert, we're always looking for volunteers. If you fancy volunteering in any way, if you're keen or got expert knowledge, it costs a whole £10 to join MEG. It's a life membership for £10. If you go to the website, you can join, and we'll be delighted to see you as a member. So we've got insulation explained. and we're introducing first Tony Cowling and then Ed Andrews. So I'll come out of that, stop sharing, and pass on to Tony, who will now do his presentation. Thank you, Tony.
Thanks very much, John.
Hang on a minute, John. There's people trying to get into the meeting. You need to let them in.
It's cruel, isn't it? Yeah, make them sit at the back. You're muted, John.
Yes, they've been let in.
So I'm going to have a little, I'm going to call this a walkabout of insulation for the next few minutes. And when I retired 15 years ago from being a builder, I was a builder for 29 years, and before that I was a research chemist. I retired rather young, and I hung up my tools quite literally. I welded them together to make a rather nice sculpture, which we're hopefully going to see in a minute. And I thought I'd just tell you about one of my favourite tools that I used to use when I was a builder, just to get you used to the sound of my voice and me droning on. Are you sharing this, John, or am I? You were supposed to be sharing my PowerPoint.
Yeah, I can do it if you wish.
Yes, please.
Righto, let me get on there. Right.
And so my grandfather used to repair his own shoes and his children's shoes, and he used to have a nice little hammer which he used, and it's the one that's in the middle of my sculpture, which we're going to see, and it has a kind of rather thin metal handle and two different size hammers on the end. And when I inherited it and when I was a builder, I used to use that little hammer as a nail punch. I used to hate hitting my fingers while holding a nail punch with a hammer, because you tend to hit a nail punch quite heavy, especially for banging cut nails into skirting boards, which I used to do in my earlier days. Later I used a nail gun. So I used to, with the red and black hammer, I used to hit the big end of that little tiny hammer and put the little end onto a cut nail in the skirting board and give it a massive whack, and it would disappear in below the wood surface. Lovely, easy for filling, never have to go back and do anything, and tights the skirting board beautifully. So next slide, please. We'll start talking about insulation now. So there's all sorts of different types of insulation. In fact, it's a massive variety, and all materials insulate to some extent, some better than others. Fiberglass is probably my favourite insulation material. It's the most economic one. Probably you might like rock wool. Modern fiberglass, despite most people's perception, is no longer itchy. It's very clever. They seem to mix it up with recycled plastic or something, so it doesn't have little bits that fly off and it doesn't make you itchy. I used to have to wear gloves and a mask. I no longer wear gloves and a mask for putting in fiberglass, although I probably ought to. And then a lot of people love sheep's wool. Very, very expensive insulation material, and it can be quite problematic. There have been problems with moths living in it if the preservative wasn't applied evenly. Once moths get in, they actually eat the sheep's wool and make their nests and cause quite a lot of trouble. So unless you're very rich and very, very green, and I'm quite green, but I won't use sheep's wool insulation, then I recommend thinking very carefully before you start doing that one. Sheet insulation, we have expanded polystyrene, extruded polystyrene, and polyisocyanate sheets, which are usually covered in silver foil. Expanded polystyrene is almost as good, but slightly better than fiberglass, and extruded polystyrene even better, most commonly used in cavity walls. And the PIR boards, you'll see them on building sites regularly used now for especially loft conversions. Not so good underfloor. I would use expanded polystyrene underfloor. If you've got a very big problem with thickness of insulation, which people do run into, especially around windows, there's things called aerogels, which are basically vacuum particles, usually in powder form, enclosed in foil insulation. Hugely expensive and only really for use in very specialist places. And then we have something which I never talk about, which is called multifoil, which is kind of very controversial, whether a single layer of foil can actually do as much insulation as a big wad of fiberglass. And I don't really want to get into that debate, but you can go and read about it yourself. So we have cavity wall insulation. I have to apologise to Instafoam and Fibre Boys because I love cavity wall insulation and I love using expanded polystyrene for the purpose, especially if you can get platinum expanded polystyrene beads. They're almost problem-free. They are reversible, so you can hoover them back out again if you're very clever, but you probably won't ever need to. I'll talk about the acronyms at the bottom, EWI and IWI. External wall insulation is really a useful thing to do, and it's commonly done in Central and Northern Europe to all houses, solid wall, 200 millimeters of polystyrene on the outside, covered with a thin mesh, and then effectively painted. It's a very thin render. It's a very good way of building a house. I don't know why we don't do it here. And then internal wall insulation used to renovate homes. Unfortunately, it takes up a bit of the room space. And we'll get on to this later. I think 50 millimeters of insulation on a wall is insufficient. So cavity wall insulation is not much use to us. Internal wall insulation at 200 millimeters thick leaves the rooms a little bit small. And every time there was an external wall, next slide, please. You have a thermal bridge going through. Next slide, please. You have a thermal bridge going, taking heat out of the house where you didn't want it.
For some reason, can you hear me, Tony?
Yeah, I can. Yeah, I can't see the next one.
Yeah, it's not moving.
There's kind of some intricacies in insulation. I've already mentioned thermal bridging. We have something which is called thermal bypass. And that would be where outside air can get between the insulation and the building. So you've got effectively convection currents of air taking heat away from the building before the insulation. So the insulation is rendered slightly ineffective. I'm sorry about this. I can try sharing this slideshow if you want, or I can just keep talking.
I'm going to launch it again.
Yeah.
Because for some reason it just doesn't want to move slides.
Yeah.
John, you can use the arrow keys.
I'm using the arrow keys and they ain't working.
Click
right.
this.
There we go.
Oh yeah, lovely. So this is me building a house, which is a little bit outrageous. We won't stay on there for too long, but I'm building a basement with no waterproofing and I'm sitting in it now and it's not damp. I used polystyrene on the bottom and then I used partial fill fiberglass in the walls below ground level. I've now filled them up with polystyrene beads. Next slide, please. So the thermal bridging psi values are how we measure how bad insulation is around windows and doors and where RSJs are. And it gives us a measure of condensation risk there. Thermal bridging and thermal bypass we've already mentioned. U values are a way of measuring the overall insulation of an element of a building, the roof or the walls or the floor. And typically U values in building regulations, in my opinion, are far too slack, not good enough. And I would like to see all U values as something called 0.1, which is several hundred millimeters of fiberglass, 200 millimeters of PIR boards. And steady state conditions are the way that U values are determined in the laboratory, and often our homes are not used in steady state conditions. We have varying temperature regimes. So the U values are maybe not so valuable as we think they are, but I still like low U values. Next slide, please. So yeah, target U values, I went into that a bit. I like less in the roof. In fact, my loft has 500 millimeters of insulation. And the calculated U values, I think, are done on average workmanship. And so if you're very careful, you can get better U values. So I would like you to think about what your target U values are. It's quite interesting if you can work out what the U value of the walls and floor and ceiling of your house are. Windows are alarming. My windows have got a U value of 0.7, which is about the same as a single brick wall. So windows usually lose a lot more heat than walls. Next slide. So this was me building my house. When I got up to the roof, I thought, how am I going to stop the heat getting out where the wall plate is? And the wall plate's the kind of horizontal bit of wood, which is near the edge of the roof. I moved mine in a bit. Mostly, there's only 50 millimeters of space over the edge of that wall plate before you get to the outside world, the underside of the roofing felt. In my house, I built sloping soffit ceilings, false scaling ceilings inside. And the insulation comes up my walls 300 millimeters thick, goes across the wall plate at 450 millimeters thick, and the insulation in the loft is 500 millimeters thick. Next slide. So that's a kind of diagram. You can find that on Tony's House website if you want to look up this technical geek stuff. But it basically means that I don't have any condensation ever in the corners of my bedrooms. Actually, I've got no condensation in the whole house. Next one, please. So typically, whenever I go and look at people's lofts, I very rarely find more than 200 millimeters of loft insulation, often only 100 millimeters. If you wanted to bump that up to 300 millimeters in your loft and you did it yourself, you would pay for that in the first winter. If you had a professional to do it, it'd probably take maybe 2 or 3 years to do it. Probably less if you had Insta doing it for you. I think we can probably go to the next one, please. Well, you'll have to look on my website to find out how much floor insulation I've got. So now I want to talk about something which I'm very enthusiastic about finding and killing, and these are called in-house winter cooling systems. And I'm going to ask you the question, have you got any of these? And you certainly don't want to cool your home in winter. It's the last thing you want to have happen. And unfortunately, a cavity wall cools your house in winter for several reasons. One, if it's not got no insulation in it, then it's got cold air from outside blowing around, which is helping cool it. The idea of cavity walls were they didn't have air blowing around in them, but every cavity wall I've ever come across has got wind blowing around in it. And even if it doesn't have, it has convection currents in there. And then a lot of modern houses built in the 80s, 90s and noughties have something called dot and dabbed wall lining. So it's a masonry house with plasterboard on the outside walls. And we often find that the draft that's in the cavity, even if it's insulated, is coming through behind the plasterboard and blowing out through sockets. When you get home, have a look and see if you can feel a draft coming out of your sockets. You may not thank me for speaking this evening if you do. Ventilated underfloor voids, either solid floors with beam and block floor or wooden floors, typically old terrace type houses, have voids under them which have to be ventilated, but they can let drafts come into your home. And cavity party walls for a while weren't allowed to be insulated, and they also are in-house winter cooling systems. So if you live in a semi-detached house, what's in the cavity between you and next door, sometimes you'll find that that wall is actually colder than the outside walls that might have had cavity wall insulation done. And it's not really what you want. Ideally, if you've got somebody next door, they should be helping to keep you warm, not the opposite effect of wind blowing in that cavity making you colder. Window trickle ventilators, I hate these. Do they actually close? Do you ever use them? Would it be worth blocking them up with tissue so that they can't be drafty? And then we kind of mentioned badly fitting floorboards. We go to the next slide, please. Floor voids let drafts come in from outside, and this is a very worrying thing. Even in the first floor of a typical house built with a cavity wall, the floor joists poke into the wall, and unfortunately when the wood shrinks after the builders have gone, a draft can come in from the cavity into the void between your ceiling of your lounge and the bedroom floor. And so now we've got cold air blowing through your house, an in-house winter cooling system, cooling the lounge ceiling and the bedroom floor. And it's really horrible. And I'd like to start a new business to cure that problem. It's not an easy one to cure. And dormer bungalows typically have that problem a lot worse. I hope you've got a letterbox flat that keeps your letterbox not drafty. Open chimney flues, bung a pillow up it. Redundant air bricks, how many of those do I find? Lots. You can usually close them up, especially if you've had a gas boiler replaced with a condensing boiler with a fan assisted flue. You no longer need an air brick. You need to check it out carefully before you do it. But I find an awful lot of those where they don't block them up when they change the boiler. Soil and vent pipe casing goes usually from the ground floor right up through the house into the loft, hole round the pipe, draft down the pipe, sometimes mice coming down the pipe, sometimes bigger things than mice, under the bath, in the bath, drafts everywhere. And then ventilated chimneys kind of wind me up a bit. the idea of ventilating a chimney came in the 60s when they started closing them up, before central heating was common. Now with central heating, all chimneys can probably be no longer needed to be ventilated, except for ones on outside walls, but even they might not. Let's carry on. I hope you're keeping up with me. I'm sorry I go quickly. Next one, please. We must be getting near to the end. How am I doing for time?
Fine, Tony. Yet again, this is frozen, so I'm going to go out and come back in again.
I can have a...
Excuse me a sec.
Yeah. So I've run something in Reading called Draft Busters for a number of years, and we did a training session where I explained to people what it was all about and what we wanted to achieve. And I put up a little kind of graphic on the screen to show a gap underneath somebody's front door and a howling gale coming in and a pussycat running away. And I didn't really think much more of it. Anyway, go next slide. So how much could you save by draft proofing? I reckon you could save £60 a year easily if you're not draft proof yet. And if you can stop the drafts, you can actually turn your thermostat down probably half a degree, maybe a whole degree, depending on how old you are and sensitive to temperature. But those two things together, that'll save £120 a year. And I like that, low-hanging fruit. Saving £60 a year, on Draft Busters, we only spend £20 per house. I do the labour-free. Next slide, please. So where do you want to look for drafts? Any unwanted gap in the construction, you'll find drafts all over the place. Windows, surrounds, underneath window boards, doors, including the frames, even through the door, letterbox. Loft hatches, have you got draft seals on your loft trap? Is it insulated? Pipes going for outside, ceiling to wall joints, they all do it. If a crack's a little bit black, it's a good indication there's a draft coming in through that crack, because it brings a little bit of dirt in the air, dust in the air from outside, and leaves it and leaves the crack or the hole where it's coming in through. Next slide, please. So this is somebody's architrave around the back door, UPVC back door. There's actually a draft coming in between the wall and the architrave. And what's the point of having a UPVC double glazed draft proof door when there's a draft coming in around the back of the whole frame, behind the lining and out through the architrave? Desperate situation. It makes insulation seem a little bit irrelevant when you've got massive drafts. Next one, please. This one is a plumber's refitted a bathroom, banged a hole for the pipe and never filled it up. So now I think she could have birds nesting under her bath, that lady, but certainly it needs cementing in. Some people use foam first and then cement afterwards. That's the opposite of insulation, an in-house winter cooling system. Next one, please. Gaps between floorboards. I think you've probably all seen them, and we might have a method of filling them up. You can fill them up with string and wax. You can fill them up with little tubey things, V-shaped plastic bits go in there. Basically anything will do. Paper mache. Next slide, please. A loft hatch. It's difficult to see that side. I'm sorry. It's a little bit black around the edges of that loft, showing it's drafty. Next one, please. This one is really amazing. If you look at that window very carefully, I don't know, we can't really make it go bigger, but you can see little black fans on it. And that's actually drafts coming in, leaving those little bit of dust on the window. And the whole crack looks quite black as well. That window was actually very drafty. And all it needed was probably a 20p set piece of draft strip up there to sort him out. Nice, better than insulation. Do the draft proofing. Next one, please. UPVC door with the draft strip actually fallen out, and all that needed to be done with that was for it to be pushed back in again. So you don't need to buy new things, you can often just push them back in again. Next one, please. Different types of draft strip. I think I'm not going to go into that, I'm worrying about time, but there's P shape, E shape, D shape, and they're all very good. I really love butyl rubber ones, like the P shape one. I quite often use one that's called an E shape. It's like a capital E in section, and they stick on. And there's also some very nice stick-on nylon brushes of all different thicknesses. The vertical ones are ones to go on the bottom of the door, sometimes a letterbox. Next one, please. That's putting the proprietary little rubber things. I think that's called Draft X. That stuff very simple to apply, and it actually looks good when it's finished, especially if you do all the cracks. The little wheelie machine pushes it halfway down. Letterbox flap. Yep, letterbox flap's good. Next one. No daylight should be visible when that's closed, and no drafts. Next one. Draft busters. That's, you can have a look that up if you like. It's got a lot of good information on there about all sorts of things, including insulation, air tightness, draft sealing. Next one. So when we went draft proofing, you would not believe what we found. Here we go. Next, yeah. That made that pussycat seem a bit more real. There was a lady living in that room behind the door. It was where she lived. Social worker, doctor, health visitor, nurse had all been in. Nobody done anything about it. And she'd spent her entire life savings on a 3-bar electric fire over the period of 5 years. By the time we finished with her, she only needed 1 bar of that fire on, and she was warm. Next slide might be my last one, I think. Yeah, so it's a tragedy that that sort of thing still happens. Like, you wouldn't have really thought in the 21st century you could have a draft under the door. So I think I'll finish there. I can do questions later. There are questions about thermostats and about insulation, so ask away for questions. I'll let the main man take over now.
Right, can we hand over to Ed, please? Ed Andrews.
Sure, thank you very much. Just seeing, can you see the screen okay?
Yep.
Okay, so good evening, everyone. Thanks, John, for inviting me, and thank you all for joining. My name's Ed Andrews, and I'm the Partnerships Manager at Instagroup. I'll give you a quick introduction to Instagroup and what we do, and then I'll go on to discuss a bit more about the new government's Green Homes Grant Scheme, talk a bit about the process and how we at Instagroup can help you through the whole journey. So Instagroup we've just gone into our 40th year of trading. We're based in working in Berkshire, and we install a wide range of energy efficiency products into residential homes mainly. However, we also have a wide range of acoustic soundproofing products and insulated flooring used in commercial buildings. This particular department is currently working on the battery power station rejuvenation. Instagroup have been working on almost every government energy efficiency scheme for the last 30 years, helping thousands of homeowners out of fuel poverty. Over that time, we built a great relationship with the government, and we actually had Alok Sharma at our offices discussing this government Green Homes Grant Scheme a few weeks back. Our core services, as mentioned prior, is loft, cavity wall, and solid wall installation, along with some heating as well. We have some good experience installing renewables as well, particularly solar PV. We've installed solar on various farms, public sector buildings, and also residential homes across the UK. We have our own approved installation products, which we distribute across the country to our network, and also within the local division here around Berkshire. Our network is called the Snug Network. It spans across England, Wales, and Scotland. We have over 70 installers. These installers are also independent SMEs, and they have a strong presence in their local communities. Finally, it's probably worth mentioning that as we have our own approved products, we have a strict onboarding process for anyone who wants to install them. Therefore, our tech team will do on-site audits, quality checks, and attend to any technical queries that might arise. Okay, so let's talk about the Green Homes Grant Scheme. The scheme was set up to enable homeowners or residential landlords to access a voucher to help towards the cost of energy efficiency improvements. There's been £2 billion put into this fund in the form of vouchers. The scheme opened at the end of September for applications and closes at the end of March next year. The government have said that the vouchers will cover 2/3 of the cost of the eligible improvements to a maximum government contribution of £5,000. So, as an example, if you were to have loft and cavity wall installation, let's say it was worth £2,100, the government will contribute the £1,400 and you would only have to pay the £700. However, if you're in receipt of benefits or in a low income household, then you'll be able to access a voucher worth £10,000 with no contribution necessary. I can share a list of the eligible benefits if needed after the presentation. However, this can be discussed in our house, in-house or with our surveyors during the survey. And onto the measures that you can install under the scheme. So like most government schemes, they aren't always as simple as they could be. There are a list of primary measures, which you need to have at least one of, to then open up the secondary measures. So the primary measures are essentially the core installation products as seen on the screen, and also some low carbon heating. The secondary measures are a bit more versatile. However, you need to have at least one of the primary measures to have a secondary. Also, you are only able to access the same or lower amount of funding obtained on the primary measure. I'll try and explain that in a little bit more detail. So if you're having loft insulation and triple glazing, and the contribution of the voucher is £500, then you'd only, for the loft, you'd only be able to have £500 for the secondary measure. So generally the secondary measures are actually quite a lot more expensive than the primary, so it's not working out that well for the secondary measures on this scheme. However, you know, the scheme is really there to kind of help the core fabric of the homes, and generally the primary measures are the most important ones that need to be done. So the application process is fairly straightforward. It's done on the government website. You will need to have a survey and a quotation from us. You'll need to tick the product you want installing, answer a couple of questions, and select Instagroup as the installer. We have been slightly surprised at the time it's taken from applying for your voucher to actually seeing the vouchers being issued. The government have issued a handful of vouchers only so far. These have been fairly manual, and they say that there's going to be an automated system launching next week. Again, I have been saying that for a few weeks now, so we'll just see what happens. And then finally, once the works have been completed, there's a voucher redemption process which has just been announced. But again, it hasn't been trialled in practice. But just to give you a few kind of comments, you would need to, first of all, pay your third contribution. We would then provide you with an invoice showing that it's been paid. We'd also provide you with the insurance guarantee for the works that's been done. And then these bits of information are then uploaded to the website, and you can then confirm that the works have been done. We would then need to go on and upload a few other bits of information as well to get the voucher redeemed. That's kind of a quick sort of run through of the application and the process. Unfortunately, it hasn't really been trialled in practice yet, so this is kind of more kind of cliff notes really, but I think over the next couple of weeks we'll be seeing some more vouchers and actually have the end-to-end journey all sort of ironed out. So it'd be quite a good time to sort of get involved with schemes, to register your interest and things like that. I just want to touch on a few points just before we finish, just around us taking COVID-19 very seriously. As being part of the construction industry, the government have confirmed that we are still able to operate during this lockdown. However, we do need to be extra careful, particularly when we're entering people's homes. So we have strict COVID-19 policy, ensuring every surveyor and technician is wearing correct PPE. They try to do as much of the survey as possible from the outside. That's clearly easier for cavity wall installation rather than loft installation. However, social distancing is adhered to at all times. Surveyors and installers will ask if anyone has in the household is experiencing any symptoms. They'll also ask for a clear path, particularly to the loft, ideally with the loft hatch already open to mitigate any unnecessary touching of surfaces, or again, time spent in the house. And finally, every installation team is very good at tidying up after themselves and making sure they are unintrusive as possible. Just on the slide here, you can see that I've put a few ways of getting in contact with us at Instagroup. If you'd like to understand a bit more about the scheme after this presentation, potentially discuss the property you're in, or if you're eligible for any of the benefits, and we can then discuss potentially about having or organising a free, no obligation survey at your home to discuss in more detail with one of our surveyors. Hopefully that wasn't too kind of whistle stop, but thank you for your time this evening, and John, back over to you.
Okay, thank you very much, Ed, much appreciated. I think we've got a fairly comprehensive idea of what you can do as do it DIY, and what you can do where you need professionals to give you perfect draft proofing of your house. but I'll hand over to Liz now. There are some questions, I think, in chat. If you can come out of that, please, Ed, we'll hand over to Liz.
So thank you, Ed. I think probably the first question is for you. I've had quotes from, this is from Paul Nicklin. I've had quotes from installers without a survey having been completed. Does this seem reasonable?
Thanks, Liz. Hi, Paul. Well, the problem we're facing at the moment is the capacity for surveying. You know, the government announced this massive scheme, eligible for everyone almost, and there's been a huge influx of interest, which is great, and of course, therefore, a huge increase in the survey requirements. Bayes and the government have said that it is acceptable to provide quotations on the back of maybe a video call survey or some photos, depending on the measures which are included in the quote. Paul, I mean, if it's just a cavity wall job, you know, we can get a good idea from photos, even sometimes from Google Earth, depending on the orientation. With loft installation, again, generally we can see floor plans online, and as long as we understand what the depth of the existing loft installation is, we can get a pretty good idea. We wouldn't give out a quotation on the back of phone call or photos. We would always try and get out to see you and, you know, discuss your requirements and maybe, you know, just talk about other areas of the house which you might not realise needs improving, particularly about the draft proofing, which you just heard Tony talk about. So we would always like to actually go to site. However, sorry, to answer your question, it's not that unreasonable, as long as it's not like a solid wall installation. I wouldn't be too worried about it, but it's probably best that they do a technical survey before installing the works.
Okay, Paul, is that all right? Do come back to me if it's, you know, you want more of the question answered. So a question from Robin Russell Jones. What about the cut-off date of 31st of March? I presume he's saying, you know, so what's going to happen after that?
Well, no, it's how they're going to spend them $2 billion before then, because
Okay.
there's only, last year, there's only 30,000 heat pumps fitted in the whole of the UK. There's very few firms that are actually MCS certified, and you've got to be MCS certified if you're going to get the renewable heat incentive back. So how on earth are they going to spend $2 billion before the end of March?
Yeah, so it's a really good question, and it's what we've been working with the government on for quite a few months now. You know, this huge input of money, this investment, to gear up the industry, to create new jobs, and, you know, and install, I think it's like 60,000 properties. It's very difficult for us to do that from standing still and finish in March, particularly over winter when there's a huge kind of external solid wall requirement in the country. We have been told that there might be potential to extend the scheme. I know that this recording is going live and it's going to go online and things. So as far as we know, that there might be an announcement about an extension. We are lobbying for an extension, and like you put so clearly, it's difficult for that money to be spent in the time limit. But as far as we've been told, there is no extension as of yet.
Well, that's interesting, because I raised it with Steve Baker, and he went to the House of Commons Library, and they sent me something that a minister had said in the House of Lords, I think, where they said the Green Grant Homes Initiative and the decarbonisation bill were being extended into 2021, 2022. But of course, they didn't say which was being extended. So it was actually a very ambiguous statement, like they were almost trying to hide what they were thinking of doing.
Yeah, exactly. And I think what you just mentioned will very likely happen. I can't really say anything more because we haven't really had the authority to say anything else, but there's clearly some things aren't quite adding up here. So I know that there are, the decarbonisation scheme will be extended to at least next September, looking at potentially 2022, and I expect the Green Homes vouchers to follow suit. But again, I can't really say anything else other than that at the moment.
Okay, thanks.
Thank you, Robin, for that, and Ed. So a question from Dave Scarborough. Now, this is very relevant for an awful lot of houses in Marlow, because a lot of houses are bungalows and then people have gone into the roof. How can one insulate an angled roof in a dormer bungalow?
Tony?
Sorry, how can one insulate an angled roof in a dormer bungalow?
I was just saying, Tony, do you want to answer that one, do you think?
Yeah, I can. Yeah,
Yeah, it sounds like your expertise.
I've done an awful lot of this. The building regulations say that you mustn't fill the void between the plasterboard and the underside of the roofing felt. In my younger days as a builder, I used to regularly insulate that full of fiberglass, and I never had a single callback. And I was a builder 15 years ago for 29 years. So that's a good 40 years of testing it out. So I have no hesitation in saying that it's okay to completely fill roof voids. In Canada, they fill the roofs of their houses with fiberglass. They just blow it in until it won't go in anymore, and it's completely solid. They do have almost no moisture in the air in Canada. It's a very drying environment, summer and winter. The real way to do it, if you want to do it properly, is you can take down the plasterboard, add some foil-faced insulation sheets in between the rafters very carefully, leaving a gap between the roofing felt and the top of your foil-faced insulation, and ideally finishing flat with the bottom of the rafters. And I would say 100mm rafter, I would be putting in 60mm of insulation between. Technically it's 50mm, but I like to add more if you possibly can. And then underneath the rafters, now you put a new ceiling up, which is made of insulated plasterboard. And for me, it's 80mm thick minimum. So now you've got 80 plus 60, 140mm of really good insulation, and that will do you a lot of good. It's going to be expensive and it's going to be very disruptive. If you want to do something slightly cheaper, you can leave the plasterboard up and add 100mm of insulation and new plasterboard. You're losing a bit of headroom in the room, which makes a little bit of difference to the side space. You should also insulate the side cheeks of dormer windows, which interestingly, as soon as it becomes a side cheek, you don't need to leave a void. So you can drill holes in there and fill it up with polystyrene beads or with fiberglass, get Instafoam and fibre in there, filling it with fiberglass. Walls can be totally filled. You don't need a ventilation gap. Roofs, including sloping roofs, you need to have a ventilation gap. The flat ceiling above, hopefully you can get into the loft and insulate that. And I like a minimum of 400mm of loft insulation. I can carry on, but I think that's probably given you a picture of what the sort of thing you should be doing is.
Yeah, thanks very much.
Great, thanks Dave for that question, because that's a useful one. And then Ivan has asked, I think this is for Ed probably, according to a government website, the Green Homes Grant money comes from the RHI, so it doesn't seem to be extra money, just money up front.
I've just put a comment in the chat because it is a bit complicated, this. Okay. And the renewable heating isn't really something that Instagroup have got that involved with, but it does sound like you can have an application for the Green Homes Grant if you're on the RHI. And it does look like the Green Homes Grant will reduce the payments of the RHI. I think there's also a link as well in the chat. It's a bit complicated, and this is sort of where they haven't really thought out the process too well. But you are right, with the renewable heat incentive, it's almost like the government don't want you really having both benefits. They do work in synergy.
So you can either have the money up front, or you can have it paid back slowly over 20 years after, but you can't have both.
Yeah, exactly. So the grant will help for the actual upfront install costs, but yeah, like Robin says, you won't be able to get both incentives.
So they are taking with one hand and giving back with the other.
That sounds familiar.
Okay.
Predictable. So Marguerite has asked, my loft is very shallow. That's 1.3 meters high at the highest. I've struggled to get someone to do the insulation. Any ideas? Maybe this is for Tony. How tall are you, Tony?
Yeah. You're on mute.
I've often done them lying down, but it
Yeah.
can be done. Like Insta would I'm not sure they're allowed to send people in now, I'm afraid. So you might need to find a local builder to do it. But it's possible to put boards down, lie on them, and gradually work your way back. You need a helper passing you the insulation. So everything is possible. It's important to leave a gap for ventilation at the edges of the roof. So you nearly need to cut the fiberglass with a pair of scissors, or like I was using on my house, an old bread knife, to give it an angle so you can side it down into the eave space a little bit, but still leaving a gap, probably 25 or 50 millimeters above the insulation between there and the roofing felt. But that is a labour of love doing it. If I lived there, I would have done it already. I'm getting a bit old for lying down in roofs now, but it's the sort of thing you can do like a little bit at a time. Do a metre on a Saturday morning and then go back next week and do the next metre, and eventually you'll get it done. And insulation being given away a while ago at £1 a roll for a big roll, which would have, one roll sounds like it might have done yours.
I don't want to do it myself. That's why I'm trying to get somebody to do it for me. But nobody wants to take the job on because I can understand it'll be tricky.
Yeah, if you'd have to find a younger version of me. There will be people who will take it on, but they will be difficult to find. It's always difficult to find people to do small jobs.
I know, that's what I found. Any ideas? Do you know anybody?
I'll ask tomorrow in our in-house division and see what they would recommend. Like Tony said, it's difficult for us because we have quite strict guidelines and we need to follow the regulations and things. But I'll see if they come up with anything, and I can send John a message and he can maybe forward it on to you.
Okay.
But yeah, I feel sorry for you 'cause it's tricky, that situation.
Okay. Any ideas would be great. Any recommendations, names? Thank you.
I have to say, if you're rolling out rolls of fiberglass, it isn't actually that difficult. You know, I actually did my mum's very old thatched cottage that had tiny little lofts, and you just sort of almost like roll it out, like chuck it out, and it goes out. You know, it's better than nothing.
Yeah, I know how to do it. I just don't want to do it.
Okay.
I want to pay somebody to do it.
Get a labourer. Okay, so we've got from Paul. Is this Paul again? Do the measures to insulate the roof in converted bungalows generally involve pulling down ceilings to get access, e.g. flat roof areas? That's an interesting one. So how to properly insulate a flat roof? I'm wondering, do you put it on the top, put it underneath? Probably Tony.
I can probably go for it. There are lots of ways. Again, you need to make sure you have ventilation. And for me, if you've got 100 mil, 200 millimeter joists, you haven't got enough room for insulation before you need to worry about ventilation. If you put insulation on top of the roof, there's a very great danger that you'll finish up with a draft in the ceiling, making all that lovely insulation thermally bypassed and not doing anything at all. So if you insulate by doing what they call a warm roof, which is insulation on top of the roof deck, then you need to make sure that joins up with whatever insulation is in the wall. And that is not an easy thing to do. You can do it when the roof is off, but it's quite difficult to see where the insulation is in the walls from on top. So you need a very good contractor to do that, somebody who's nice and diligent. For small areas of flat roof, I'd have no hesitation of filling the void completely. Like Insta probably wouldn't do it with their guarantees and stuff, but you could fill that void between the ceiling and the deck of the roof, and effectively you suddenly turn that into a warm roof with no ventilation. And it's semantic argument as to whether that is a warm roof or it isn't a warm roof. And you need to have a vapor barrier on the ceiling if you do that. So there's different ways of doing it. I'm afraid I've been a builder for a long time, and builders cheat, and I'm probably one of the worst cheats there is. And a small flat roof, a dormer window roof, I'd have no hesitation in just filling the whole thing. Probably with polystyrene beads, you can blow them in. If you want to take the ceiling down, you can do it. You could take down a small patch of ceiling. You could take off the gutter and the fascia, shove insulation in through there. For goodness sake, insulate it. The easiest way to do it is to put a sheet of insulated plasterboard underneath the ceiling, And then basically you know already that it's going to join up with the insulation in the walls, always assuming that there is insulation in the walls, which is not necessarily the right assumption to make, I'm afraid.
Great, thanks, Tony.
I'm sorry, I'm naughty. I'm very, very naughty. You should really do it properly if you possibly can.
Great, thanks. I've actually got a question about your ventilated underneath floorboards, so Victorian houses.
Yeah.
You know, what should we be doing? Are we just stuffing up the old vent bricks? Can you do that? You know, is there any way out of it?
Basically, you mustn't do that. It's bad because there will be a certain amount of condensation going on in underneath the floor. And at the moment, it's a very drafty place, so any condensation is automatically blown away by wind. It's very tempting to block those air bricks up, but it can be problematic if you do it, especially in older houses. They rely on that ventilation to keep them dry. So the most important thing from my point of view as a draft buster is to make sure that there are no drafts whatsoever coming from under the floor into the house. It's far more important to do that than it is to insulate it. So that is between every floorboard, between the floorboard and the skirting, and in older houses, a draft can go up the end of the floorboard, up behind the skirting and out the top of the skirting. Victorians didn't used to plaster behind skirtings. They used to plaster from the top of the skirting upwards. So that is a really nasty problem. And then if there's a socket in the skirting board put in by an electrician a long time ago, that will be drafty. And then it gets even worse as we carry on talking. The draft can come up the edge of a floorboard behind the door lining, which often there's a gap behind the door lining all the way up where they've got wooden packers and nails and all sorts of stuff going on. And once it's in that gap going up behind the door lining, it can get on top of the door lining. It can come out from behind the architrave. And I've even seen it come out from the latch hole where somebody's drilled a hole for the latch keep, drilled it right through the bit of wood, and a draft is coming out in a latch keep in somebody's dining room, which is 8 feet from the outside wall, and that's outside air blowing out of that. It's just remarkable what you can do. So foam around the skirting, around the edge of the floorboards is really a useful thing to do. Not easy if there's carpets down, very easy if you're redecorating. You can push envelopes, newspaper, old polythene bags, anything under skirtings, and we've had a look at different ways of doing between the floorboards. If you've got a carpet, you can masking tape them. I've got pictures on the Draft Busters website of a lady who had cold feet in her kitchen, and I went round, I took the plinth off the kitchen cupboard, and there were actually 2 floorboards missing underneath her kitchen sink, which a pussycat could have climbed up one and down the other. And when I put them back in again or boarded over them, she had warm feet for the rest of her life. So watch out for whole floorboards missing, understair cupboards, typical places for floorboards missing, big gaps around pipes, radiator pipes. If you want to insulate the floor, you can go underneath. If you can get underneath, you can insulate from underneath quite easily. It's not easy if it's lying down on your back. You can also take up the floorboards, and I've many times hung a strawberry net between the joists,
Yes.
put fiberglass insulation down between, and then I actually like to have a vapor barrier under the floorboards, even though you nail through it a lot. And that goes up behind the skirtings, which then get refixed with the vapor barrier, which is now an air barrier, trapping out any air. And that makes that room lovely. Like, it will make it loads warmer. It's an expensive sort of job to be doing. And then if I want to start being naughty, I've applied for grants to fully fill underfloor voids with polystyrene beads, possibly lacquer, which is expanded clay balls. And I would love to see people doing that. Unfortunately, a lot of people have objections to doing it for often reasons that I don't particularly agree with, but maybe ought to be researched. I know somebody overseas who's filled his entire family's underfloor voids with polystyrene beads between 5 and 10 years ago without a problem. And it's, again, if it's a void, it's got to be ventilated. If it's not a void, then what do building regulations have to say about it? It can't possibly need ventilating because there's not a void anymore. And I don't know whether I really want to go on about this, but everybody thinks damp is going to come up into the building in that circumstance. I've got half a degree in physics, and damp will actually move from the building down through the insulation into the ground, which is not what everybody thinks, but it is what happens physically. It's a downhill process. And so it's kind of safe to do it. And I'd love to see every house in the country, especially concrete suspended floors that are drafty, filled with polystyrene beads. There are technical issues involved, and research should be done on it. But as I say, I know somebody who's done it to a load of houses 10 and 15 years ago, and it doesn't seem to be a problem. I would not do it if I were you, but I will come and help you do it if you want. I'm looking for volunteers.
We might experiment and come back to you on that one, Tom.
It'd be a lovely experiment to do, and to come. I've thought about doing it on a house that I own, but unfortunately I sold it before I did it.
Okay, yeah, well, because I think the Victorian houses are the most difficult ones to sort
They
out.
are. The draft proofing is the crucial thing. If you do the draft proofing, you will be a lot warmer, and especially if you start getting it where I've explained, you've got it recorded, so you can come back to me. I'm not allowed to be sued, by the way, for anything I say.
Great, thank you. Does anyone else have any other questions?
Yes.
Oh,
Okay, go on, Alan. Let me get to a different view.
Can you insulate from the inside? I live in a block of flats, and there's a rendering on the outside of the building, which it'd be difficult to drill because they would leave marks in the rendering. Can you insulate walls from the inside?
Yes, you can do the same thing as you do from the outside. You would need to redecorate. So Insta will come along and drill all the holes for their cavity wall insulation from inside, and then you have to make them good. And it's a bit difficult. They will actually be very good at making good holes in render from outside, but it may be a scaffold job now, so it might be better.
Yeah, it would. It's a 3-story building, and it's leasehold. Yeah. I mean, I guess if I wanted to drill from the outside, I'd ask the leaseholder. Yeah. But if I did from the inside, would I still have to ask the leaseholder?
Probably you would. I'm sure the lease will say something like that. I'm not sure that the leaseholder could do much about it. It's going to be difficult to insulate one flat in a block because you need to stop that cavity insulation dropping down ever after it's been done into the people below. So you'd have to have a kind of a brush or something in there that would restrain it.
And is that possible?
Yes, I ought to get Ed to do that, I think. Do you want to do it, Ed? Sorry.
It's something that we can do. It's very tricky, like Tony mentioned, and it all depends on what's on that exterior wall on the inside. If you have a kitchen against it or a bathroom, that kind of thing, it always has issues.
Is it possible I can ring Ed Andrews at the Instagroup to talk about this? Can that be done?
Yeah, absolutely. Yeah. Do you want to take a phone number?
Yeah, I'm ready when you are, please.
So it's 0800
0800, yeah.
526
526, yeah.
023.
023. I'll just repeat that for good order. So it's 0800 526023.
Yeah, that's right. Yeah.
Okay, perfect. I'll give you a call tomorrow if I may, please.
I've put the number in the chat if anyone needs it.
Okay, that's very kind of you. Thank you. I'll follow it up from there. Thank you for your help.
Okay.
Thank you.
Liz?
Yes, we are at 8 o'clock.
Yes, can we draw it to a close
Yes.
if it's all right with you? Can I first of all thank Liz for doing the question and answer session. I'll give you a quick anecdote. 30 years ago, we moved into a bungalow without cavity wall insulation, which was damp and cold. We had cavity wall insulation put in by a company called Instagroup, would you believe?
Okay.
And the next day, the house was warm and dry. It is
okay, good.
miraculous change when you have cavity wall insulation put in. Can I just close by apologising for the slightly hesitant slide presentations? I don't know what went wrong then. Can I also remind you of our Ask the Experts in December 8th of December on National Grid, energy, power, etc. Can I remind you that if you haven't joined MEG, i.e. Marlow Energy Group yet, please do. And can I lastly thank everybody for coming and wish you well and say goodbye.
Okay, thank you.
Thank you, everyone. Thank you, John. Thank you. Particularly thank you, Ed and Tony.
Yeah, Ed and Tony. Yeah, I should have said that. Thank you, Ed and Tony. Hugely appreciated. Thank you.
Bye.
Thanks. Bye.
Bye.
Thank you.